Hello everyone, welcome. This is the second of 9 webinars in the Highway Safety Manual training series. This session focuses on providing a high-level overview of the Safety Analyst software. By the end of this session, you will be familiarized with Safety Analyst and the tools and modules in Safety Analyst. I will also demonstrate some of the capabilities of Safety Analyst. The main takeaway from this session is to understand that Safety Analyst is a very powerful tool that automates the steps described in Part B of the Highway Safety Manual. I am Priyanka Alluri, Assistant Professor in the Department of Civil and Environmental Engineering at Florida International University. If you have any questions about Safety Analyst or this session, please feel free to email me or call me anytime. Safety Analyst provides state-of-the-art tools for safety management that provide capabilities beyond those currently available to highway agencies. Safety Analyst automates all the steps in the roadway safety management process. It incorporates the approaches described in Part B of the Highway Safety Manual. Why use Safety Analyst? Safety Analyst can be used to proactively determine which sites have the highest potential for safety improvement as opposed to reactive safety assessments done conventionally. Safety Analyst integrates all parts of the roadway safety management process into a single software package. Safety Analyst automates state-of-the-art statistical approaches as described in Part B of the Highway Safety Manual. We can use Safety Analysts to identify locations with greatest potential for safety improvement and create 5% reports. We can perform site-specific diagnosis to identify crash contributing factors and crash patterns. We can select countermeasures. We can conduct economic appraisal and prioritize safety improvement projects. And finally, we can evaluate countermeasures. Here are some of the capabilities of Safety Analyst. It automates all the steps in the roadway safety management process. It automatically divides the entire road network into predefined site subtypes. It performs quality control and identifies problems with the datasets. It applies empirical-based method and ranks problematic sites based on their potential for safety improvement. And finally, it provides expert system to diagnose site conditions and collision patterns and suggest potential countermeasures. Safety Analyst was developed in a pool fund effort managed by FHWA and sponsored jointly by 27 state highway agencies and interested local organizations. The development of Safety Analyst began in April 2001. White papers defining initial plans for the functionality of the software tools were completed in 2002 and 2004. The interim software tools were completed in 2006. The development of the final software tool was completed in 2010. Safety Analyst consists of a set of multiple independent applications or tools that interact with the database. This figure illustrates the relationships and the flow of data between the Safety Analyst applications. Safety Analyst consists of three primary tools: the administration tool, the data management tool, and the analytical tool. The administration tool is used to set up and manage the Safety Analyst deployment. The data management tool is used to import and prepare an agency's inventory, traffic volume, and crash data for analysis. The analytical tool is used to conduct safety analysis of an agency's inventory. There are three categories of safety analyst users. The administrators and the data managers use the safety analyst administration and data management tools to prepare safety analysts and the agency data for use by safety analysts. And finally, the analysts use the Safety Analyst Analytical tool to conduct safety analyses on an agency's inventory. The data management tool provides capabilities for highway agencies to create and maintain the Safety Analyst database, including data on crashes and the characteristics of roadway segments, intersections, and ramps. Within the data management tool, the user can create dataset profiles and import, post-process, and calibrate data. The user can also report and export the final datasets. The administration tool operates with three separate and distinct databases: the federal database, the agency database, and the system database. The federal database is a read-only local database that is distributed with the administration tool. It contains federal default data plus national averages for the crash distributions. The agency database is a local database that you maintain using the administration tool. It is the repository for the agency's specified deployment attributes. Finally, the system database contains the merged federal and agency data and is the source of that information for the Safety Analyst Analytical tool. Within the administration tool, we can edit several data, including the data attributes, agency site subtypes, agency countermeasures, diagnostics data, agency specified SPF data, and cost related default parameters. This figure shows a pictorial overview of the Analytical Tools framework. A workbook contains an inventory profile and site list. A site list contains analyses. The user level is at the top of the Analytical Tool framework. Safety Analyst can support multiple users on a single computer. A workbook is the second level of the Analytical Tool framework. A workbook is associated with a single inventory profile, a set of data to be processed. From the inventory file, the user can create site lists. A site list is a sub-level of a workbook and contains all or a subset of the sites in the inventory associated with the workbook. As safety analyses are conducted on the site list, those analyses are listed under the site list. Within the analytical tool, we can perform all the steps in the roadway safety management process. We can identify locations with the greatest potential for safety improvement. We can perform site-specific diagnosis to identify crash contributing factors and crash patterns. We can select countermeasures. We can conduct economic appraisal and prioritize safety improvement projects. And finally, we can evaluate countermeasures. This figure illustrates the safety analyst application process for Florida. It further provides the interactions and the data flow between the data converter and the different components of safety analyst. The only new component in this process and specific to Florida is the data converter. The data converter was developed to convert Florida data into the standard format required by safety analyst. The converter has the capability to generate all the required import files for segments, intersections, ramps, and their associated crash and traffic files. The output from the converter can be directly inputted into the Safety Analyst Data Management tool. In summary, roadway safety management is a data-intensive, statistically complex, and computationally rigorous process. Safety Analyst automates all the steps in the roadway safety management process. Safety Analyst requires minimum statistical expertise. Data requirements are intense, however, it is a one-time process. Safety Analysts can play an important role so that the agencies get the greatest possible safety benefit from each safety dollar spent. Safety Analysts can be used to create safety assessment reports based on rigorous data analysis to secure safety funds and justify their use. FDOT had participated in the development of Safety Analyst and has been working toward deploying the application. There are three main concerns pertaining to Safety Analyst deployment in Florida. The first main concern is that the Safety Analyst has stringent data requirements. To address this concern, we developed a conversion program to automatically generate Safety Analyst import files. However, we need to update the program to include data from non-state roads. The second main concern is that the Safety Analyst requires Florida-specific safety performance functions. We developed Florida-specific SPFs to use with Safety Analyst. And the third main concern is that the Safety Analyst has steep learning curve. To address this, we will provide technical support and expert advice on Safety Analyst. As I mentioned at the start of this session, the main takeaway is that the Safety Analyst is a very powerful tool that automates all the steps described in Part B of the Highway Safety Manual. Now, let's move on to the software demonstration. Safety Analyst has three major tools: the administration tool, the data management tool, and the analytical tool. It also has the implemented countermeasure management tool to assist data managers in managing the data on implemented countermeasures. In this session, I would like to focus on the analytical tool. However, I would like to quickly open the administration and data management tools to show their interface. When you install Safety Analyst, it appears in the programs as Astoware product. Go to All Programs and click on Astoware Safety Analyst. The application includes the analytical tool, the administration tool, the data management tool, and the implemented countermeasure management tool. The user's manual for the analytical tool can also be accessed from here. When you click on it, the manual opens in a web browser. This is the analytical tool user's manual. First, let us open the administration tool. To open the administration tool, click on all programs, Use Safety Analyst, and the administration tool. The administration tool is used to set up and manage the safety analyst deployment. Within the admin tool, we can edit several data, including the data attributes, the agency specified site subtypes, agency specified user permissions, agency specified countermeasure data, diagnostics data, agency specified distribution data, the SPF data, and the cost parameters. For example, we can click on the cost parameters and edit the cost associated with a fatal injury and a severe injury and so on and so forth. We can also edit the EPDO weights for the fatal severe injuries and so on and so forth. For now, let me click cancel and close the administration tool. Now let us open the data management tool. Go to all programs and click on Use Safety Analyst and the data management tool. As we are logging into a local database, a username and password are not required. So let us click OK. The data management tool is used to import and prepare an agency's inventory, traffic volume, and crash data for analysis. Within the data management tool, we can create dataset profiles and import, post-process, and calibrate data. We can also report and export the final datasets. Here, all the datasets created by me are listed. So let us click on the most recent dataset profile. This data includes the data from the entire state of Florida. Let us click OK. This dataset includes the import files for segments, intersections, ramps, and their associated crash and traffic data. Once the data are imported, we need to post-process and calibrate the data. The calibrated data could then be exported. Note that this is a useful capability since Safety Analyst has already cleaned and processed the data for us. Now let me close the data management tool and let us open the analytical tool, where all the steps in the roadway safety management process could be performed. Go to all programs, Use Safety Analyst, and click on Analytical tool. Again, since we are logging in to a local database, a username and a password are not required, and let me click OK. If we are using the analytical tool for the first time, a Getting Started wizard appears and it helps us get started with Safety Analyst. After we become more familiar with the software, we can conduct the analyses without the help of the Getting Started wizard. Since this is the first time we are using Safety Analyst, let us follow the steps provided by the wizard. Let us click Next. And now we can select where we want to conduct an analysis. We can work in an existing workbook and a site list. We can work in an existing workbook and create a new site list, or we can create a new workbook and a new site list. Since this is the very first time we are analyzing this dataset, let us create a new workbook and a new site list and click Next. Let us give today's name to the new workbook, 09/11/2016, and let us select the most recent dataset that was imported, post-processed, and calibrated in the Safety Analyst Data Management tool. And the distribution source would be the dataset specific distributions. Let me click Next, and let us name the new site list as Monroe County. Since in this project I want to analyze all the road locations in Monroe County, let us click Next. And now we created a new workbook and a new site list by name Monroe County. However, there are no sites in the site list. We can add sites to the site list by clicking on this button. When you click on this Add button, we can either add all sites or add sites using a data item query. Or we can also add all roadway segment sites or all intersection sites or all ramp sites. Let us add sites using a data item query since we want to include all sites in Monroe County. Now a site selection query wizard appears, and let us begin a new query and click next. Since we want to analyze all sites in Monroe County, let us hit on specify county and next. And the Monroe County code is number 90, so let me select 90 and click next. Since we want to analyze all sites in Monroe County, let us hit finish and hit run, that is to run the query. As you can see here, county equal to 90, that is Monroe County, resulted in 574 sites. And these are all the sites that are listed here. Now, till now, we've created a new workbook and a new site list by name Monroe County and added all the sites in Monroe County to the site list. At this point, if we want to remove some specific sites, we can click on the remove button and remove some specific sites. Since this is what we want to analyze, let us click next. Now, in this window, we can select how we want to use Safety Analysts. We can either conduct network screening or the diagnosis and countermeasure selection module, or the economic appraisal and priorities ranking module, or the countermeasure evaluation module. Let us start with the first step in the roadway safety management process, that is network screening. Since it is already selected, let us click next. Now we've selected to run the module network screening, and the new workbook name is 09/11/2016, and the new site list that we created is Monroe County. Let me click finish. Now as you can see on the left panel, we see the 09/11/26, that is the new workbook that we created, and we have a new site list Monroe County, and under this site list we have a module that is network screening 1. And this is the window for the network screening module. On the left panel again, we can see a link to the user's manual. If we click on the link, the help menu within Safety Analyst opens and provides more guidance on how to perform the network screening. Let me close this window. And on the right of this network screening module window, we have the report type, that is whether to conduct the conventional network screening or percentage report by site type. And also we can choose the screening type, whether we want to do the basic network screening with peak searching on roadway segments and CV test, or basic network screening with sliding window, or the high proportion of specific crashes, or a sudden increase in mean crash frequency, or a steady increase in mean crash frequency. Let us go with the default values, that is the conventional network screening and the basic network screening type, and click next. On this page, we can select the crash severity levels that we want to analyze, whether we want to analyze total crashes or fatal and all injury or fatal and severe injury or PDO crashes. We can also select the safety performance measure, how we want to rank sites based on, whether we want to use rank sites based on expected crash frequency or excess crash frequency. And also we can choose the analysis periods. For now, for this exercise, I am leaving everything as the default values. That means we are going to analyze total crashes, and the safety performance measure is the expected crash frequency. Let me click next. And here we have the crash frequency limiting values. As you can see, the default value is 5 crashes per mile per year for roadway segments, and 5 crashes per year for intersections, and 5 crashes per mile per year for ramps. And now let me click next, and we have the crash screening attributes. Let me use the default value, that is the crash month, and let me select all the months so that all the crashes are analyzed, and let me click next. And here we have list of the items to be included in the output. All the items in the right window will be included in the output. So if we want to exclude one or two variables from the output, we can select them and click the left arrow here. However, since I want to include all the items in the output, I'm leaving the result as is and clicking next. As you can see, the panel on the left gives more details about network screening. Here let me click next, and as you can see in this window, all the options that we chose are provided. Let me click run. and the report is open in the web browser. As you can see, you can click on number one, network screening report. Here we have all the information that we entered, and here we get the table one, that is a basic network screening, the final result. We have the roadway ID, the segment, site subtype, county, route number, the site location, start location, end location, and the observed crashes, the average observed crashes, and so on and so forth. If we scroll down towards the end of the report, we have another table that lists all the sites that are excluded from the analysis due to missing or incomplete data. As you can see, a few of the segments are excluded from the analysis, and the reason for exclusion is missing or invalid site subtype. Let me go to the top and close this window. We can also see the report in an RTF format or the HTML format or the PDF format. If I click on the PDF report, the report is open in a PDF format. And if you scroll down, we have information about the network screening results. This is the information that we inputted for this network screen step, and this is the output from the network screening module. Let me close the PDF report. Similarly, we can also open the report in an RTF format, and this is the output in the RTF format. Dismiss. So far, what we have done is we have created a new workbook and a new site list by name Monroe County, and we perform the first module, that is network screening. And if we want to rerun the analysis, we could highlight the network screening and click on rerun the analysis. At this point, I don't want to rerun the analysis, so I'm clicking on cancel. And if we want to, we could display the report in the HTML format, PDF or RTF format. We can also display the report in CSV files. We have those three separate CSV files. We could have one for the title sheet, one for the screening results, and one for the excluded sites. Once the network screening is completed, we could click on Monroe County and the site list appears. As you can see, we have two new columns here. One column is valid, that tells whether a site is valid or not, and the other new column is screening rank, which provides the rank based on the network screening output. If we click on screening rank once, all the sites are arranged in ascending order, and if we click on it again, the sites are arranged in descending order. For now, let me keep the sites in ascending order. Similarly, we could click on any other columns, for example, site subtype, roadway ID, or route name, or county, and sort the sites based on either ascending or descending order. Let me click on site subtype, and now all the sites are sorted in ascending order. Since we are at the site list level, the site operations tab, the analyze crashes and details are grayed out. But if we click or select one site or a location, these options will become clickable. For example, let me choose one location, say urban four-leg signalized intersection, and this intersection experienced 9 crashes from 2011 to 2014. Now, when I clicked on this specific location, as you can see under the site operations, the analyze crashes and details tabs became clickable. Double click on a specific location. A new window appears, and this window provides detailed information about the specific site. For this intersection, the first tab is the general intersection data tab, and in this tab, all the general information about this intersection, such as the intersection ID, the major road location and minor road location, the GIS identifier, the latitude and longitude, the site subtype, the intersection type, the number of legs, etc. are provided. If we click on agency defined data, since we have nothing in this one, this tab is empty. If you click on the traffic data, it provides the major road and minor road ADT data for all the 4 years, that is from 2011 to 2014. The leg data tab provides more details about each approach of this 4-leg intersection. The crash data provides detailed information about all the 9 crashes that occurred at this intersection. As you can see, we have 9 crashes. that occurred at this intersection from 2011 to 2014. We could click on a specific crash and then click on display. A new window appears with more information about this specific crash. For example, it has information about the date and the time and whether the alcohol or drug involvement or not, the crash type or manner of collision, number of vehicles involved, the lighting condition, weather condition, etc. It also provides more information about the vehicles involved in this crash. We could again click on a specific vehicle and then click display, and a new window appears with more information about the specific vehicle. For now, let me click dismiss and dismiss. And we can also, at any point, we could also click on the site map, which provides the aerial view of this location. This is the four-leg intersection that we are analyzing, and this intersection experienced 9 crashes. This is a very important and useful application to conduct site-specific analysis. Let me close the window. There is also another tab called Implemented Countermeasure. Since we have not implemented any countermeasures at this location, this tab is empty. At this point, let me click Dismiss. And again, as I said, if we select one specific location or a site, the site under the Site Operations, the Analyze Crashes and Details tabs become clickable. If we click on Analyze Crashes, we have three options: whether to generate a crash summary report, a safety performance report, or a collision diagram. Let me first click on the crash summary report. As you can see, a new window appears and we have several sections to select. For example, in the selection criteria, we could select the analysis direction. Let me for now leave everything to be the default values. So the default value is the crash severity is total crashes. In the summary items, these are all the items that will be included in the crash summary report. For now, let me include everything. And in the report configuration, let me just leave it as is, that is the default values. But just to give you more information, the details will include the site details section. It also includes the crash details section, and it will provide the bar charts as well as the pie charts and the tables. Let me click OK. And right now, Safety Analyst is running this crash summary report for this specific location. Once the report is generated, it will automatically open in a web browser, and this is the crash summary report for this intersection. This is the roadway ID and this is the milepost. On the right, we have the table of contents, which provides all the subsections that are included in the report. We also have the list of tables and the list of figures. Let me first click on the crash summary, the first section, and this section discusses the summary of the crash data associated with the specific intersection. As in the notes, you can see that the summary includes 9 total crashes between 2011 and 2014, and the intersection is an urban four-leg signalized intersection. The first table provides the crash numbers by each year, and the next section focuses on the alcohol or drug involvement. We have the statistics in a table and in a bar chart as well as in a pie chart. Similarly for all the other subsections as well. For example, bicycle indicator, we have one bicycle crash that occurred at this location. So we have the information in a table format and then in a bar chart as well as in a pie chart. It also provides crash numbers. For example, we could click on a specific crash number and it provides very detailed information about that crash only. Let me close this for now. After reviewing the crash summary report, let us look at the safety performance report. Again, the safety performance report setup window appears, and let us leave everything to be the default values, which is total crashes in terms of crash severity, and the analysis period is all available years. Let us click OK, and the report is being generated. Once the report is generated, the report is open in a web browser, and on the right hand side again we can see the table of contents, and we have just one table, that is the safety performance. This report contains the safety performance statistics for one single intersection, and this intersection experienced a total of 9 crashes between 2011 and 2014. If we look closely at the table, the first column in the table is the intersection ID, and then we have the site type, which is an intersection, the site subtype, which is a four-leg signalized urban intersection. We have the route ID and the route milepost of this intersection. The analysis period is 2011 to 2014, and as we all know, the total number of crashes this intersection experienced is 9 crashes, and the average observed crash frequency is 2.25 crashes per year. And the average predicted crash frequency is calculated from the safety performance functions, and it is 2.53 crashes per year. The average expected crash frequency is 2.26 crashes per year, and which is the weighted average of your observed and your predicted. A positive excess crash frequency indicates the site experiences more crashes than expected, and in this case we have a negative excess crash frequency, and which indicates that the site experiences fewer crashes than expected. And the magnitude of the excess crash frequency indicates exactly how many more crashes are expected at the site above what is considered normal for sites with similar conditions. The modified LOSS, which is level of service of safety, is similar to the LOSS concept presented in Chapter 4 of the Highway Safety Manual. However, in Safety Analyst, the modified LOSS represents the amount by which the expected crash frequency falls above or below the mean predicted crash frequency, and modified LOSS of 1 indicates a low potential for crash reduction, while LOSS 4 indicates a high potential for crash reduction. Let me close the safety performance report. And if I go back to the safety analyst analytical tool, and under analyze crashes, the third option that we have is the collision diagram. A collision diagram is a visual representation of the crash history at a given site. Each crash is represented on the diagram with schematic arrows and symbols. Abbreviated text may also be used to provide additional information about the crash that cannot be easily illustrated, such as the time of the day, the pavement condition, weather conditions, severity level, etc. And this is a window to set up the collision diagram. Again, let me just use the default values, which is total crashes, and the analysis period is all available years. Let me click OK. As you can see, this is the collision diagram for the four-leg signalized intersection, which experienced a total of 9 crashes from 2011 to 2014. As you can see, of the 9 crashes, 6 crashes were drawn, while 3 crashes were not drawn. Here, you could also see that the schematic text, and in this case, the schematic text is lighting condition. At the bottom of the diagram, we have more information about the analysis parameters and the site description. On the top ribbon, the first icon gives the legend, and it gives the schematics for angle and rear end crashes and the collisions with pedestrian and bicyclist. And lighting condition captions are also provided. Let me close this. And the second icon gives the list of crashes that were not drawn and the reason. At this location, 3 crashes were not drawn, and the reason being they were work zone related crashes. Let me close this window, and the next one is to set up your printer, and the next icon is to print the image of the collision diagram. We could also zoom in on the collision diagram or zoom out of the collision diagram, and also zoom to full size of the collision diagram. If we click on the view icon here, in addition to show legend and list undrawn crashes and zoom in and zoom out, we also have information about the schematic text, where we could change the schematic text from, say, lighting condition to, say, severity level by clicking on it. And we could change the schematic text size from small to normal, and we could also choose an option to draw work zone crashes. And if I select that, all the 9 crashes were drawn at this intersection. At any point, we have the help menu, which explains about this collision diagram viewer. Let me close the collision diagram viewer. Now let me cancel the site list, and as you can see, so far what we had done is we created a new workbook and named it as 09/11/2016, and we created a new site list by name Monroe County. We performed network screening, and then we looked at one site. Now let us perform diagnosis. by clicking on the Diagnosis tab here. And let me choose the intersection that we have just looked at and click Next. At this window, a new window appears and it asks us to provide diagnosis analysis parameters. Let me leave everything to be the default values and click Next. And now within Safety Analyst, we have three tools available to identify crash patterns of interest at a given site. The three tools are the crash summary, collision diagram, and statistical tests. We have already looked at the crash summary and the collision diagrams, so let us focus on the statistical tests. Safety Analyst provides two basic statistical procedures for identifying crash patterns of interest for diagnosis and countermeasure selection. Statistical tests can be performed based upon crash frequencies and/or crash proportions. Overrepresentation of a crash pattern may be indicated by a large count of crashes of a given crash type or a large proportion of those crashes as compared to proportions for similar sites elsewhere on the agency's highway system, or a combination of both. Let me select both the test for frequencies and test for proportions, and the minimum crash frequency let me change from 5 to 1 crash per year, and let me leave the alpha to 10%. And test items, let me leave them as is, the default values, and click OK. Now the statistical tests are being performed and the report is generated, and we could look at the report in HTML format. Let me click on the crash statistics, and this report contains crash statistics for the site. This site, as we all know by now, it experienced a total of 9 crashes between 2011 and 2014. The minimum crash frequency threshold that we chose was 1 crash per year, and the p-value is 0.10. In this table, this is the average observed crash frequency, and this is the average expected crash frequency. The next column, observed proportion, is the proportion of crashes for each specific crash type relative to all crashes for the given severity level that occurred at the site. And the limiting proportion is the proportion of crashes for each specific crash type relative to all crashes for the given severity level, but it is based on the crash data distributions for sites of the same site subtype. And the probability observed proportion exceeds limiting proportion. It gives the probability that the observed proportion is greater than the limiting proportion. And crash types are highlighted in this column if the probability is greater than or equal to the confidence interval specified by us. In this output, in the final row for total crashes, columns for average observed crash frequency and average expected crash frequency are highlighted because the average frequencies are greater than the limiting value of 1 crash per year. Also, for pedestrian crashes, that is collision with pedestrians, the probability observed proportion exceeds limiting proportion is highlighted because there is at least a 90% probability that the observed proportion for this specific crash type, that is collision with pedestrian, is greater than the limiting proportion. To go to the top and table of contents, let me close this window and go back to this. Now, since we have looked at the crash summary report, the collision diagram, and the statistical tests, let me click on the diagnose. In this window, we could select one or multiple crash patterns of interest. For now, let me select collision with pedestrian and say rear end as the crash patterns of interest, and then hit next. Now, let us click with the collision with pedestrian, and we want to analyze all vehicle maneuvers and hit next. And we could perform diagnosis. We have just one scenario ID for collision with pedestrian. Let us select that and click on diagnose. Now a new window appears with a set of diagnostic questions. Diagnosis summary is also provided here. So the questions here we have is, are crashes with pedestrians occurring? I would say yes, because we had one crash with pedestrian, and click next. Are there pedestrian sidewalks on the intersection approaches? I would say yes, because we had sidewalks at this location. I would and click next. Do pedestrians encroach onto the road while waiting to cross or waiting to board transit? Let me click yes and click OK. So depending on my response, Safety analysts recommended two countermeasures. One is to provide or increase pedestrian storage area, and the other countermeasure is to relocate transit stops. The next question is, are there pedestrian signals and or marked crosswalks at the intersection? I would say yes because I remember seeing marked crosswalks at this location, and let me click next. During peak pedestrian periods, do pedestrians encroach beyond the marked crosswalks? For this, let's say I don't know the answer, so let me just leave it as unknown and then hit next. Do pedestrians have difficulty crossing the road within the given time and overflow onto the next phase of the signal? Let me say yes, and depending on my response, four more potential countermeasures were recommended. That is, install pedestrian countdown signal heads, increase pedestrian crossing time by implementing a leading pedestrian interval, install curb extensions, or install raised median at marked crosswalks for use as a pedestrian refuge. The next question is the intersection located within a school zone? I would say no and then click next. The next question is, are the pedestrian traffic volumes sufficient to consider separate phases or separate walkways? Let me click yes. And next, are pedestrian crashes occurring at night? Let me say yes. Are clear daylighting triangles in accordance with local standards and clear of sight obstructions? I would say yes and click OK. And now the diagnosis is complete, and these are the recommended countermeasures based on our responses to these questions. At this point, let me click finish. We've completed reviewing one scenario for pedestrian movements. We could go back to pattern selection and choose rear-end crashes and the different type of vehicle maneuvers. Let's say rear-end crashes involving two changing lanes or two through movements, and click next. And these are several scenarios that could result in rear-end crashes. So let us select one scenario, say dilemma zone, and hit diagnose. Again, we have a diagnosis summary and then a set of questions. On the top of this window, we have the click to display the map and the depth, and the map could be this is the site map. We could zoom in. Okay, so we could have this open and then dismiss this one. And the questions are rear-end crashes occurring at this intersection because drivers are having difficulty making stop or go decision when the signal turns yellow? If I say yes, is the signal warranted? Let me say unknown. And the next is, are adjacent signalized intersections within 800 meters of this intersection? Let me say yes. Is the signal at this intersection coordinated with preceded signalized intersections along the corridor? Let me say no. And for that response, safety analysts recommended three countermeasures, that is, install dilemma detection system, provide signal coordination, or add advanced detection. The next question is the clearance interval appropriate for the cross section, the design vehicle, and the posted speed limit? Let me say no. And the next recommended countermeasure is improve change plus clearance interval. And the diagnosis is complete, and let me hit finish. Let me close this. And based on this diagnosis, safety analysts recommended four countermeasures, and there are contraindications for a few countermeasures as well. If I want to, we could continue evaluating the different scenarios to come up with all the possible countermeasures. At this point, if we know that there is a countermeasure that we want to implement, we could simply go to add countermeasure, and we could just add a countermeasure. For example, I would say improve change plus clearance interval, and I'm assigning this countermeasure. uh, One countermeasure is sufficient, so let me hit OK. Once the scenario 16 has been diagnosed, we can go back to the main window and select a different scenario to perform the diagnosis, or we could go straight to the countermeasure selection. This point, let me go to the countermeasure selection, and in this window we have the recommended countermeasures. If you remember, scenario number 16 is dilemma zone, And scenario number 50 is the pedestrian movement. So here are the different other side diagnoses that we could perform, but at this point let us finish the diagnoses and click OK, finish. And now the diagnosis and countermeasure selection report is generated. And again, on the right, we have the table of contents and the list of tables. Let us go to the first section in the table of contents. And it provides the site summary for this intersection. As you can see, it provides all the information about this intersection. And then if you scroll down, we have the major road and minor road annual daily traffic, and we have information about each intersection leg. If we scroll down, we also have the list of recommended countermeasures and the scenario ID. For example, for the scenario ID number 50, where the recommended countermeasure is provide or increase pedestrian storage area. We also have another column that tells whether the countermeasure is already present at the location or not. And here we get the summary of potential diagnoses. For the first one, that is diagnosis number 16, the dilemma zone. The crash pattern we analyzed is rear-end crashes, and vehicle maneuvers is like two through movements. And evaluation is incomplete. That is because at least one diagnostic question has not been answered. We have the statement and the rationale and the question and the answer and the recommended countermeasures based on our answers. If you scroll down, we have for the next diagnosis number 50, that is the pedestrian movements. Again, we have the statement, the rationale and the questions, answer and the recommended countermeasures based on our responses. If you scroll down, we have other diagnoses that we have not evaluated. So for example, we have the traffic congestion, that is queuing, and as you can see, it says here that it's not evaluated. Let me go back to the top and to the table of contents, and after this we could go to the second section, which provides the descriptions for recommended procedures. It provides more information about this one. And we close the report and go back to the safety analyst analytical tool. Again, we could review the report in a PDF format. This is the diagnosis and countermeasure selection report in a PDF format. It is the same information obviously in the PDF format. Let me close this, and again we can also view the report in the RTF format. Let me click on dismiss. If we want to, we could select the diagnosis on the left panel and then click on rerun the analysis to perform the analysis again. However, we could close it for now, and if we highlight the diagnosis, we could also choose to display the report in either HTML, PDF or RTF formats. Since we completed the diagnosis, let us go back to the site list and click on the economic appraisal. As you can see, now the site list has more columns. Besides the screening rank, we have three more columns. We have the, if you can see it, we have recommended countermeasure count, proposed countermeasure count, and the proposed countermeasures. So let me see. Let me click on the intersection that we've been working with. That is the location intersection that had 9 crashes, and we don't have any proposed countermeasures because we did not propose any countermeasures yet. But based on the earlier diagnosis and countermeasure selection module results, safety analysts recommended 13 countermeasures. Let's go to the edit proportional countermeasures. This is the new window. As you can see, we have the recommended countermeasures that are checked and the countermeasure ID, category, the title, and we also have the crash modification factors for total crashes and fatal and injury crashes, and CMF functions, and also the cost associated with these countermeasures. We could click on, say, a specific countermeasure and then click on assign. That means we are assigning that specific countermeasure to this location. Okay. Let us choose one countermeasure, that is improve change plus clearance interval, and since it has a CMF for both total and fatal injury crashes, so let let us hit assign, and if we have an updated CMF, we could update the CMF here for total final condition and for fatal and injury crashes, and we could update the service life. I'm going to leave it as is. And the unit construction cost is $2,000. So let me hit finish, and this is the one proposed countermeasure. Say we could also propose a different countermeasure. Say for example, install a right turn lane, and then hit assign. Install right turn lane, number of intersection legs to be improved, let's say 2 legs on the major street. So I hit next, and then this is the total construction cost. Let me hit finish. Let us see if we could identify one more. Say increase median width, intersection median width by 3 foot increments, and we have the CMFs for total and fatal and injury. Let us hit again, assign again, number of intersection legs to be improved. Let's hit 2, and then next, and then let's say finish. So we are proposing three different countermeasures. That is okay, so let us hit okay, and then we could go to the next. Now the economic appraisal, we need to select the economic criteria. We have cost effectiveness, EPDO based cost effectiveness, benefit cost ratio, and net benefit. Let us select everything, and at this point, if we need more information about the economic appraisal module or the priority ranking process, we could go back to the user's manual. Here is a link to the analytical tool user's manual. Let me click on the link here. Here is the user's manual in the within the Safety Analyst web browser that provides more information about the economic appraisal and priority ranking. For now, let me close this and click next, and let me leave everything to be the default values, that is the available years. Analysis period is from 2017, expected implementation is 2017, and the number of years to analyze is 20 years. Let us hit next, and these are the crash costs by severity. We could leave these crash costs as is or change them. Let me leave them as is, then hit next, and these are the crash weights by severity. Let me hit next, and these are the ranking criteria. We could select just one ranking criteria or multiple. Let me hit control key and select all the ranking criteria, and the countermeasures are to rank based on the highest ranked countermeasure for each site. No, let us rank all countermeasures, and then hit next. And if we have a certain construction budget, we could optimize net benefits within the construction budget. For example, we could click on that, and the total budget could be, say, something like $1 million. And then after we input all the required information, let us hit run, and the economic appraisal report is generated. Again, the report is open in a web browser. On the right hand side, we have the table of contents. Let me click on the first section, that is a summary of input parameters. It provides the summary of all the input parameters that we just entered. And the first table gives you the site countermeasures data. We have three countermeasures for the same location. And then we could click on next, where we have the summary of the proposed countermeasure inputs. It provides information about the CMFs and the growth factor and construction cost for all the countermeasures that we are evaluating. And we could click on next and go to the economic appraisal. Here again, it provides information about what we entered and the crash costs. And the table 2 gives you the information about the economic appraisal. We have three proposed countermeasures, and you can see that the cost effectiveness value, cost effectiveness EPDO value, you have the benefit to cost ratio, and the net benefit ratio. As you can see, one countermeasure, that is increase intersection median width by 3 foot increments, is not gonna improve safety, and also it's gonna have a negative benefit cost ratio. Uh, and the best scenario in this case would be improve change plus clearance interval, because with a benefit cost ratio of 88. Next, let me go to the priority ranking. Again, it gives you all the information that we entered, and the priority ranking based on cost effectiveness. Again, the first countermeasure, that is to improve change plus clearance interval, is ranked 1, and the next one is the installing right lane, that is ranked number 2. Similarly, the same ranks are given based on cost effectiveness, EPDO, and the benefit to cost ratio, and so on and so forth. Next is the optimization. Since we said that we have a budget of $1 million, so the optimal solution is we need to pick one countermeasure, that is to improve change plus clearance interval, and the total crashes reduced is 3.58, and this is just an estimated number. And the total cost. And next we could click on the summary of the site details, which provides the summary of the site specific information. Let me go back to the table of contents and then close this window. Again, we could see the report in a PDF format and the RTFs format. For now, let me hit dismiss. After performing the economic appraisal, the next step is to evaluate countermeasures. This could be done by clicking on Countermeasure Evaluation module on the left panel. A new window appears, and on the right let us choose to evaluate construction projects. And evaluation type, let us leave the default value, that is to estimate percent change in crash frequency. Let us click next, and here we could select the construction projects that we want to evaluate, and we have two construction projects here. One is to install lighting at an intersection, and this lighting was installed in September 2012. Then another construction project is to install left turn lane, and this was done in October 2012. Let us select both the construction projects and click next. Let us leave everything to be the default values and click next. Here we have an option to adjust the analysis periods. Let us leave the analysis periods as is and click next. Now we can evaluate the countermeasures based on either total crashes or fatal and injury crashes or fatal and severe injury crashes or PDO crashes. Let us select total crashes and then click next. And the crash attributes, we could evaluate it based on crash month, day of week, vehicle turning moment, or crash type and manner of collision. Let me choose crash type and manner of collision and click next. Here we want to evaluate all crash types, so let us select all and then click next. And on this page, the summary of the evaluation parameters are provided first, and then we could click run. Once evaluation is complete, the results are opened in a web browser. Again, on the right, we can see the table of contents and the list of tables. Let us go to the first section in the table of contents, that is a summary of input parameters, which provides, as the name implies, the summary of all the input parameters that we just provided. And the next is project evaluation for installing lighting. As you can see, the table 1, we have the odds ratio and the effectiveness, and table 2 provides the evaluation based on the empirical base approach for the project installing lighting and for total crashes. As you can see, the result is a 31.65% reduction in crashes after this countermeasure is implemented. We could click next to go to the next project, that is installing left turn lanes. Again, we could look at the table, and this from the table we could see that installing left turn lane resulted in a 41.74% increase in crash frequency. That is all that there is to the countermeasure evaluation module. So let me go back to table of contents and close the browser. Again, if we want to, we could view the report in a PDF or in an RTF format, or we could dismiss. So far in this exercise, what we have done is we have created a new workbook 09/11/2016, and we've created a new site list by name Monroe County. We then performed all the steps in the roadway safety management process. We started with network screening, and then the diagnosis, countermeasure selection, and then economic appraisal, and finally countermeasure evaluation. Uh, we have completed a quick demonstration of Safety Analyst. In the demonstration, we've created a new workbook and a new site list Monroe County. We have performed the network screening module. We conducted site-specific analysis. We have generated crash summary report, the safety performance report, and the collision diagrams for one intersection. We have selected countermeasures. we've conducted economic appraisal, and we've also evaluated countermeasures. Thank you very much. And if you have any questions about safety analyst or this session, please feel free to email me or call me anytime.